folks, welcome to our talk. We're going to talk to you today about how to secure your infrastructure from code to cloud. So a quick introduction, I'm Ben LaPlanche. I'm a product manager on the Snyk Infrastructure as Code product, and I'm here with my colleague.
Hi, my name is Camille. I'm a senior security engineer on an infrastructure as code team.
Thanks, Camille. So in our talk today, we're going to focus on three main things. The first one is we're going to talk about what is infrastructure as code. Next, we're going to talk about app development and the role of infrastructure as code that it plays in that. And then lastly, we're going to talk about some principles for a secure and repeatable deployment process. So first of all, let's just reset some context on what is infrastructure as code and how can it help you? So infrastructure as code, the clue's in the name a little bit. Really, it's about, as a developer, you're able to define your infrastructure in code using tools like Terraform, CloudFormation, or maybe as your resource kind of manager templates. And what this enables you to do is by treating it like code, you can version it, you can use continuous deployment techniques. This allows teams to be empowered to provision what they need. And we've really seen these techniques and this pattern of infrastructure as code popularized by the adoption of cloud, certainly over the last few years. Now, let's set the scene in terms of personas. When we think about infrastructure in general, when we talk to our customers, we see three main people in the mix. There's the application security team, who are very well known and kind of close to our hearts at Snyk. They're responsible for setting the overall security standards that the infrastructure should be adhering to. You've then got the infrastructure team. Sometimes these may be referred to as infrastructure developers, maybe a platform team, DevOps team. The names may vary, but ultimately the responsibilities are the same. This is about defining cloud best practices and providing tooling to those development teams. And of course, we have the developers themselves who are working on the applications. They're responsible for deploying and running their infrastructure. Now, we've drawn this as a Venn diagram because the overlap between these three personas can vary, and that may vary based on the customer, and it may even vary by the teams within that customer. And some of the factors that we often see are this. The overlap between infrastructure and app development teams can vary based on the level of maturity and understanding, some of which is powered by tools and also knowledge on the teams. So if app developers have got mature tooling and lots of context, then maybe the infrastructure teams need to be less involved and there can be more decentralization. And when it comes to security, there's a similar concept at play. If there's well-defined security standards that are well understood and you have automated testing and tooling in place so that teams can get regular feedback, then you can also kind of have more decentralization and more empowerment to the app development teams. And this is going to be the thesis of our talk today, is to how to enable the app developers. Now, if we dig in a bit further, specifically with infrastructure as code, the security team, infrastructure as code enables them to have repeatable and approved processes that they can roll out. But it can make it hard to enforce that consistent security posture end to end. From an infrastructure developer perspective, infrastructure as code is great because it enables the standardized best practices and tooling, but it can create a visibility gap on what gets deployed. And that's because the infrastructure team themselves are no longer the ones doing the actual deployment now. And for the app developers, infrastructure as code enables autonomy to deploy what they need, but it can highlight this gap in knowledge and skills in order to do this well. There's not just new tools they need to learn, but there's all of these concepts around the cloud, what great infrastructure looks like, and of course, what secure infrastructure looks like. We found from a survey that Snyk ran that only 7% of the nearly 500 respondents rated themselves as using infrastructure as code to the best of current industry standards. And what this says to me is whilst there's a lot of appetite to adopt these tools and these ways of working, there's still a bit of a hurdle for teams to overcome in order to feel like they can do this confidently and securely. So with that context, let's move on to talking about app development specifically and the app developers and how infrastructure as code helps them. We've really seen this shift from the centralized operations model of like, here is my Jira ticket for you to provision the infrastructure that our application needs. So this is app teams making requests to somebody else. Two, here's Terraform, so we can define and deploy the infrastructure ourselves. This is app developers being empowered to take on more responsibility and make the changes that they need. But as always, with a shift in responsibilities can come some of this friction that we just talked about around the tooling and around the knowledge. So let's keep digging in there. The developer challenges that we see that people face in particular, we broadly think of in these three buckets. You've got complexity. Like, what is the right infrastructure to use? What standards do I need to follow? From a visibility perspective, how do I know it worked? Has my cloud environment deployed as I expected it to? And feedback, of course, the concept is very near and dear to any developer's hearts. Like, how do you know that you're secure? And how do I know that I'm compliant, especially to any internal standards that may have been set? And in particular, that feedback is important so that you can iterate early. So you want to get the feedback in the right part of your development lifecycle. So what we think about this as Snyk is we believe that development teams who are embracing infrastructure as code want to take ownership from the code that they're writing in their local development environments all of the way through to what is getting deployed and run in their cloud environments. And this is how Snyk approaches application security in general. We want to make sure that we can give you security feedback at the relevant part of your software lifecycle. So whether that's the local development, integrating into your repository, maybe your CI/CD processes, and we'll talk a little bit about cloud as well. And this enables the app teams to take ownership. But to do this, they need that feedback on their security posture. So they need this consistent feedback loop as they see changes go around the lifecycle. And of course, they need the visibility of that as well. And this is all in service of enabling them to make safe and secure changes. So ultimately, you are only as secure as what gets deployed and run in your cloud environment. Now, that can all seem a little bit daunting. So let's dig into some principles that we can explore for a secure and repeatable deployment process. Underpinning infrastructure as code, there's a core set of principles that speak to the theory of what can be achieved. On this slide, it can look a little bit overwhelming, but this is an example of a development and deployment pipeline that is very common best practice for using infrastructure as code. And we've highlighted here the different principles that are in play and how they relate to solving some of those particular problems for the app developers. So ranging from the complexity through to the visibility and feedback. Now, I'm not going to dig into each of those here. I'm going to hand over to my colleague, Camille, who's going to talk us through each of these principles in practice using a worked example along with the Snyk platform fully integrated so that you can see this working hands-on. So for the first part of the demo, we're going to talk about how to develop your infrastructure locally. So over to you, Camille.
Thanks, Ben. So what we're going to do, we're going to use an example of deploying an ECS service to our development environment and progressing it through to our production environment. In our team, we're using GitHub to manage our code centrally. We're using Terraform to manage our infrastructure as code, and we're using Terraform Cloud as our continuous delivery system. So let's get started and see how Snyk can help us secure our environment. So we're going to go into our development workspace. We're going to work in small iterative batches. We're going to follow trunk-based development model for this part of the demo. I'm safe that Ben is watching us do this. So let's go ahead and deploy and add an ECS cluster. Let's add that into our version control system. And what we can see here is Snyk IIC being integrated into our local development via pre-commit hooks, we've been informed that container insight was disabled in our configuration. However, in our organization, we use Prometheus to manage metrics, so we can create a safe exception to ignore this specific issue at a time. So let's use Snyk ignore functionality to do that. We're gonna give it a good reason. It is used to manage metrics and try to commit once more. And what we can see here that our Snyk IIC test has passed. Now we're being asked to sign our commit. Signing commits allows us to make sure that changes are attributed to correct users. Next, we can add our task. We're gonna use simple ECS task with EFS backend. Let's add that into our version control system again. And what we can see here that Snyk IIC once more identified two issues. This time, it identified that we might have potential secrets in our configuration. Storing secrets in version control system is insecure because anybody with access to that version control system will be able to read your secrets and reuse them. For ECS tasks, we can use IAM task roles. Alternatively, we could use AWS Secret Manager or services such as HashiCorp Vault to store secrets securely. So let's delete the secrets from our configuration. What we can see here is that issue was identified before we committed anything into Git history, which keeps that secret secure. And let's commit that in one more time. And as you can see, issue has been resolved. So this is how we can secure our local development environment with Snyk IIC. Back to you, Ben.
Thank you, Camille, for that demo overview. So let's talk about some of the principles that we've just seen Camille cover off. So under the banner of complexity, we've got this concept of working in small iterative batches. What you saw there was Camille kept looping through, responding to the feedback and making small changes in order to get quicker feedback. From a foundational perspective, we understood the importance of externalizing your secrets, and of course, talking about the importance of storing your code in Git. If we just recap a little bit more, here you've got the Snyk CLI. Camille used this to ignore an issue that we decided wasn't relevant for that particular application. This is a great example of where you can make overrides at an application-specific level from your security posture. And of course, using the Snyk infrastructure as code CLI in order to also detect those secrets. So now let's go back to another demo, and this time talk about how to deploy securely and in a repeatable way. Over to you, Camille.
Thanks, Ben. So in previous demo, we've committed our code to Git. Let's push that to our deployment pipeline. So what do we have to do? Run git push. Terraform Cloud is using a Git webhooks to identify when there is changes made to our repository, and what we should see that Terraform plan has been triggered for our development pipeline. So let's go and see the details of the run. This pipeline has been configured with Snyk IIC integration, which will allow us to detect any potential issues during deploy time. This way we can catch changes that were introduced through variables that were configured in our continuous delivery system rather than code. And as we can see here, the Snyk IIC check has identified one medium severity issue. We can go ahead and look into Snyk platform to see what is the issue. And what we can see here is that EFS has been configured with non-encrypted drive. What we can do in order to fix this, we can go to our variable settings and see that this needs to be changed to true in order to make sure that our drives are encrypted. And we can rerun the same pipeline safely through trigger. Let's wait for the plan to complete. As we can see, the plan has completed. Now we're going to trigger the same Snyk IIC test as before. And this time the pass was successful. So we're going to go ahead and deploy this to our development environment. And as we can see, our deployment has completed. What we can quickly do is go to our development console, refresh, and we can see that our cluster was deployed and our service has been deployed. The next thing to do is to test that our deployment is working correctly. So what we have here is a simple integration test implemented with TerraTest. TerraTest is an open source tool that allows us to integrate directly with our Terraform workflow. We have configured 3 tests. We'll be checking if our cluster is in an active state. We will be checking if our service is in an active state. And we will also check if our task is running with a correct desired amount of replicated containers. So let's go ahead and give it a go. We need access to our development environment, and we can use standard Golang test capabilities to run our test. The test will fetch information from our Terraform Cloud workspace to identify the desired outputs, and then it will communicate with our deployed cloud to validate the issues. And as we can see, all of our 3 tests are passing, and we are ready to start progressing this to our production environment. But before then, Ben, back to you.
Thank you, Camille, for that part of the demo. So again, let's recap some of the principles that Camille has just shown us in practice. Under the banner of visibility, we just saw an automated pipeline deployment in practice. And this is important because you want to treat this like code. So you want to use those pipeline continuous deployment principles here. And this example was using Terraform Cloud. Under the banner of feedback, we saw integration tests. So this was the TerraTest example that Camille just showed you. This allows you to know that the changes you're making are actually going to do what you expect. And then, of course, the security scanning perspective as well. That's another type of testing that's really important here, and that you should be integrating using tools such as Snyk infrastructure as code. So if we just recap here, what you saw as part of that deployment pipeline that was powered by Terraform Cloud, which is a new integration, is a partnership between Snyk and HashiCorp. You can see that as part of that run, the Terraform plan was sent to Snyk for processing, and security results were returned accordingly. Equally, if you're not a Terraform Cloud customer, that's okay. It's a powerful tool, but you can also recreate a similar experience using the CLI and then a CI/CD pipeline yourself. So here, this is a quick example showing how you can grab the Terraform plan output using the Terraform CLI and also pass that Terraform plan output into the Snyk CLI. You can see here, you'd be getting the same type of feedback. So let's go to the last part of the demo, where Camille is going to show us the needs that are tailored towards the security persona around setting a security standard. Over to you, Camille.
Thank you, Ben. So we're ready to deploy our ECS service to production. For this part of the demo, we're going to switch to pull request feedback loop. So we're going to create a quick branch. And we're going to add, we're going to copy our development configuration into our production workspace. We feel that because our deployment worked correctly in development, everything should work smoothly in our production deployment. So let's add our configuration. And as we can see, local checks have passed, and we can push our branch upstream. Using pull request allows our colleagues to review our changes ad hoc, but it also gives us ability to configure more security tests as part of the flow. So we're going to quickly create a quick PR. As we can see, a reviewer was automatically assigned to our PR, and we can also see that there is more tests that are running as part of this process. And fair enough, one of the tests has failed. So let's have a look. What is the issue? This check was powered by the Snyk IIC custom rules, which allows you to define organization-specific rules written in Rego that you might want to enforce. In this case, it detected that we are not using a pre-approved Terraform modules to deploy our ECS task definition. Terraform modules allow us to write unit tests and keep our configuration dry. So what we can see here in our version control system, that there is a number of modules that we could be reusing. And one of those modules is ECS cluster. Additional benefit of using modules is that we can import them into our Snyk platform and continuously monitor the security posture of that configuration. What we can see here is an example of the ECS cluster module and an issue identified regarding the configuration. As we mentioned before, container insights are not really used in our organization. Another feature of Snyk platform allows us to configure our security standard that meets our needs. What we have to do is go to infrastructure as code settings, find the policies that we want to change. So in this case, what we want to define is that ECS container insight check will not be applicable in our organization. And we can retest our project one more time with the security standard modified. And as we can see, the issue has been resolved. We can track the progress and changes of our security with historical view of changes. Let's go and address the feedback that we received in our PR and modified our production environment to use an approved module. So what we're going to do is we're going to use the module instead of the definition. And we also going to change our task to use module as well. And let's go ahead and add our changes to the branch. Let's refactor our commit. No issues. Let's push that to the branch. And what we should see here is that our PR checks are being rerun with the new commit. And hopefully we should see that our custom check will be successful this time. And that is the case. All of our tests have passed. So let's go ahead, merge this into our production environment. We can safely delete the branch now. What we should see here is that our production pipeline has been triggered. Let's see the details of the run. This pipeline has been configured with Snyk IIC integration as well, which means we can be sure that the same security posture is applied. And because we went through all of the security improvements in our development pipeline, our production is safe and secure. Let's deploy that to our production environment now. I'm just going to wait for the run to finish. And our production environment has been deployed. Let's quickly have a look on our production account. We can see that the cluster is deployed. Instead of looking at it manually, we can go ahead and rerun the same test that we run in development in our production environment to validate that everything is configured as expected. This time we're going to connect to our production environment and we're going to run the test. the Terraform is gathering the information and running our integration test. And as we can see, the production environment has successfully passed all the tests. And this is how we got our ECS service deployed from development all the way down to production. Back to you, Ben.
Thank you, Camille, for that part of the demo. So again, let's look at some of the principles that Camille has just demonstrated for us here. Now, both of these fall a bit more under the complexity banner. So first up, you saw Camille talk about using a pull request-based workflow. What this was really demonstrating was the power of peer reviews, or kind of doing a code review in order to get that feedback. And the important piece of feedback here was around the use of reusable code, specifically the Terraform module. We'll see what impact that had for us. So here, as part of that demo, you saw Camille had the Git repository integrated with the Snyk platform. This is powerful because it gives you that assurance that you've got the continuous monitoring in place. So every time Camille made a change and pushed that out, the Snyk platform detected it and was continuing to rescan it. So as an app security persona, you can keep an eye on this and get centralized dashboards on this security posture. We also saw how you can tailor the security standard to meet your needs. So we got this piece of feedback about this particular rule, but actually it doesn't apply to this particular use case. So Camille went ahead and disabled it. So this is a nice example of being able to tailor the rules that are important to you. Here, you could also override the severity and again, tailor that to meet your needs from the Snyk provided default. This is a great example of where a project that you've imported to the platform, you're able to look at the history of it. The reason this is valuable is because you can see the progress that is being made on taking action against those issues that have been raised as app developers make changes and continually get more secure. So you can see the progress that was made here as we move from having that one open issue to 0. Now, custom rules is something that we are adding into the product right now. And this is valuable because it allows you to augment the Snyk provided rules with logic that is custom to yourselves. And specifically here, we saw a really nice use case of custom rules checking that a particular module is being used if the AWS ECS task definition module is being used. And we also saw here, as part of that pull request-based workflow, that these checks, and in particular this custom rule that we just added in, can be run and then enforced. So again, here as an app developer, you are getting feedback in the place that matters to you the most, including Snyk provided rules, as well as those custom rules that have just been added into the product by your own security team as well. So that brings us to the end of the demos. So let's recap what we're taking away from this. So we had these 3 main areas of complexity and feedback that we hear from app developers. The first one was around complexity itself. So here, the takeaways for you would be, remember to work in small iterative batches, leverage code reviews such as the pull requests in order to get peer feedback, and look at how you can enforce standards through code reviews. So that was the Terraform modules example that we just saw. From the visibility perspective, make sure that you're deploying via pipelines only. This helps you know where the changes have come from. And also ensure that you're setting up continuous security monitoring and testing to go with that as well. And then last but not least, of course, feedback. This is where the automated testing of your infrastructure is really going to serve you well. And importantly, make sure you get security testing to be part of that. The Snyk Infrastructure as Code product, we've shown you, cuts across all of these areas and can really help you achieve this vision of having app developer owned infrastructure from the code that they're writing locally through to the cloud environment that it's been deployed and run onto. So thank you very much for attending our talk. I've been Ben and my colleague Camille. Thank you.
Thank you.